I think talking data to the business is kind of a topic that no one really teaches you. So I'm lucky because I came from a business background and I frankly didn't know all these technical terms until I started studying data later on. So I had kind of an advantage that I would already know what the business people like to hear or which terms they're familiar with. How do they like to frame their communications in a way that the main points get across first?
Hello, everyone. Welcome to the Data Scientist Show. Today we have Sunishchal Dev. Dev is the lead data scientist at Booster. He's helping to decarbonize the transportation industry by optimizing last-mile delivery of renewable fuels. Previously, he was a management consultant. On the side, he volunteers with Project Drawdown to model the most effective solutions to climate change. He is also a mentor of future data scientists at Springboard by guiding them through real-world projects. Today, we'll talk about his career journey, supply chain optimization, how data science can help the environment. If you like the show, subscribe to the channel, leave a comment, and give us a 5-star review. Welcome to the show, Dev.
Thanks, Daliana. It's nice to be here.
How did you get into data science?
Yeah, I took kind of an interesting journey. I started out in business. That's what I studied in school. And then I went into management consulting. And I did a variety of projects, but the one that was most interesting to me was an AI implementation for like a large manufacturing firm. So I wasn't doing the data science myself, but I was prioritizing the most valuable use cases for AI and automation. And I got to work with data scientists every day and saw how cool it was. So I was like, maybe I can try this coding thing myself. And one thing led to another. I went to a boot camp, I learned the coding, and then I found myself in an AI startup when I moved to San Francisco.
Yeah, thanks for sharing that journey. So what was your first project at the AI startup? What did you do?
Yeah, so it was called Noodle AI. Has nothing to do with pasta. This was a supply chain optimization company. So we were basically trying to reduce industrial waste by predicting supply and demand and giving supply chain planners actionable recommendations on how they can be more efficient with their deliveries. So the data science problem here was, of course, the forecasting. So we were trying to ingest data from big enterprise resource planning systems like SAP and see if we can correlate different parts of the business to better predict that supply and demand.
And what was the biggest challenge of that project?
So choosing the right target variable, I think, was pretty tricky. I joined pretty early when it was Series A. So this was before we had a product. We were kind of just going to different enterprises and saying, hey, we have a bunch of smart data scientists. Can we solve some problems for you? So it was really kind of starting from scratch and climbing our way up from the bottom. And you'd be surprised at how difficult it is to go from having a business problem to a machine learning model that you can actually use to solve the problem. So a quick background on supply chain. The most important metric is fill rate or fulfillment rate. Basically, what percentage of orders are you able to actually fulfill? And this is tricky. Like say a customer orders 100 widgets and you're shipping 100, but a box of 10 gets lost in transit. Now you have a 90% fill rate. That's a problem. And we could have fixed it ahead of time if we knew that shipment was going to get lost and we could have ordered extra or whatever. So we went into this company and we were like, okay, let's predict the fill rate. If it's below 100, then we'll do something about it. So we went ahead and started by doing that. And very quickly we realized that's not the right thing to predict. First of all, when you have a target variable that's bounded between 0 and 100%, your ML model is not going to do a great job. It's going to kind of average things, and it'll always be like 99% or 5%. But in reality, the majority are either 100% or 0%. It's not really that often that it's in the middle. So we realized that, yeah, we could change the modeling approach, but this might actually not be the right target variable. Because even if we do predict that your fill rate's not 100%, what are we going to do about it?
Yeah.
It's not that actionable or interpretable. So what we decided to do is instead break it into two target variables, your inventory and then your demand, because that's essentially what you use to arrive at fill rate. You take your inventory divided by your demand, and that should give you the percentage of the demand that you fulfill. So this worked out a lot better for us because now we can either tell that the demand is actually higher than we thought it would be, so we need to make more stuff so that we can fulfill it. Or we might find out that the inventory is lower than we thought it was going to be, and we need to move things around from a different warehouse or something like that to fix the problem. So after doing that change, we were still able to calculate fill rate. So the business users had their interpretable KPI that they cared about. But in the back end, we had an interpretable model, which we can use to give actionable recommendations.
Yeah. Thanks for sharing this project, because I have similar experience. When you try to use a ratio as a target variable, it's very hard because the ratio has different components. And each components, in your case, the supply and demand, have their own distribution. So instead of predicting this ratio, it might be easier just predict a more tangible target variable.
Yeah, exactly. I think a lot of data scientists face similar problems when they're starting out.
Yeah. What are some other interesting problems you were working on?
Yeah, it was interesting that I ended up in supply chain because when I was in school or whatever, I never thought that would be a problem I'd work on. It's not the most sexy industry to be in. It's like literally shipping boxes around. But the thing that was fascinating about it to me was how big of an impact a small improvement can have. Because there's millions of boxes being shipped around every day, and one bad decision can lead to a lot of waste.
Yeah.
So being able to optimize that and make even a small improvement to the KPI can result in millions of dollars saved for the business and lots of carbon saved from the bad shipments that we make that don't end up in the right place. So that's what really got me sold on the whole supply chain thing and made me decide to take my career deeper in this direction. And the other interesting problems that we solved here, this is still at Noodle AI. Once we had our product market fit and we realized okay, this is something that can help lots and lots of enterprises, then the problem moved a little more to the back end. How can we deploy these models very efficiently at different customers? And we decided to start building out a sort of a data science platform that is tailored towards supply chain use cases. So I started building out components for data ingestion, feature engineering. We also had a team working on something called core inference that would try lots and lots of different algorithms and just tell us which is the best for this data that we're working with. So that was super interesting from an engineering perspective.
Yeah.
And it's way harder than you'd think, just because of all the different formats that the data can come in, all of the different things that the businesses care about. It's not always quite the same. Some care about, some are like perishable goods, so they care about shelf life. Others last forever, but they care more about customer satisfaction, so fulfilling all the demand. And based on these different problems, you might want to use a different algorithm or a different feature set. So that got really interesting on how we can make horizontal assets that solve all these problems.
Yeah. Some type of the work you did sounds like data engineering, or in general, data science engineering. You're building tools to make your future project easier. So how do you like this type of engineering work compared to building predictive modeling?
Yeah, it's a good question. I would say I prefer the modeling over the engineering because engineering comes with a lot of, let's say, baggage. You have to write test cases. You have to think about everything that can go wrong. If something breaks, then you get a call at midnight.
Do you have to be on call?
Luckily, no.
Yeah.
But I know that is a common thing that happens, right? Pager duty. So I do prefer the modeling. But more importantly, I prefer looking at the insights from the modeling and tuning and tweaking and making decisions about how we can improve things. And that's not going to happen unless you have good tools. So I see this as like the means to an end. once we had these great tools built,
Mm-hmm.
we could rapidly iterate and do more of the strategic data science work and see like which evaluation metrics are working for us, what can we change in the loss function, this and that. That's the really interesting work to me.
Yeah. Thanks for sharing that. And when you work with customers, how did you interpret a model to them?
Yeah, that's the tricky thing. So a lot of these supply chain planners, they've never even heard of machine learning in their lives.
Yeah.
So we kind of had to start from the basics. When we would go to a new customer, we would explain from the ground up, like, what is AI, what is machine learning, what is analytics, and we would try not using any technical terms, right? We would try and translate everything to the business terms that they're familiar with.
Mm-hmm.
How is this going to impact your KPI? When it comes to model interpretability, we don't say anything like Lime or SHAP or stuff like that. We say this shipment is at risk because, there's bad weather or something like that. So we try and really distill everything down to their language, which is actually hard for a data scientist because we love our lingo, right?
Mm-hmm.
So that was definitely a growth area, but I think it created a lot of value for our customers.
Yeah, thanks for sharing that. So instead of using those data science statistical terms, you put it into a scenario. If something happens, this is the potential outcome, so they can understand the risk factors there.
Yeah, exactly. Giving those tangible examples helps a lot. And it requires you to have a lot of empathy for your users.
Mm-hmm.
Really get in their shoes, shadow them, see which challenges they actually face on a day-to-day basis. So then you can contextualize it for them and make sense of it.
Yeah. And what are you working on right now?
Yeah, so right now I'm at a company called Booster. You can think of us as like the DoorDash for fuel. So what
kind of fuel?
We do all kinds. So we do gas, diesel, but the really exciting thing is renewable fuels like biodiesel.
Okay, got it.
So this is something that's got me really excited because it is, I think, one of the fastest opportunities to decarbonize our transportation industry. So just explaining how the operations of it works, we have these 1,000-gallon tankers that we drive up to big fleets like Amazon or UPS, and we'll refuel all of their vehicles in their parking lot overnight. So now they don't have to worry about going to the gas station anymore. They can just show up and do their routes, and they save, first of all, time that their drivers would spend doing those refuelings. Gas, driving back and forth to the gas station, that is actually about $1,000 per vehicle per year of wasted gas and time that we're saving them.
Yeah.
And the really exciting thing to me is once we're fueling them, we can snap our fingers and switch them over to renewable diesel overnight. And now they're hitting their sustainability targets, and they didn't have to do anything. They just had to give us the thumbs up.
Yeah. So what kind of data science problem are you trying to solve in the space?
Yeah, so it's interesting. I'm working on the routing optimization problem. We have lots of different customers that we have to hit every night, and the less time we're spending driving, the more efficient we are and the more profitable we are.
Yeah.
So I'm sure you've looked at similar problems at Amazon, right? So we have this constrained optimization solver that will, look at the delivery time windows, how much fuel we have in every tanker, this and that, and it'll give us an optimal route. But there's some probabilistic inputs that are needed. I need to predict the demand for each of these customers, and I need to predict how long we'll spend doing each delivery so that we can have accurate time blocks to shuffle around in the solver. So those are time series forecasting algorithms that I've built. And we have 4 models in production right now for various use cases. So those are the data science problems I'm mostly focused on.
Yeah. And I'd like to dive deeper in those models. So let's start with the constrained optimization. Is it purely a mathematical problem you're trying to solve?
Yeah, that's right. So it's like linear programming. I didn't work on that part of it.
Yeah.
There's much smarter people than me that are solving that problem. But this falls into like operations research.
Yeah.
So like constrained optimization, finding the lowest point in the convex, and that's what gets us our route. But the better the inputs are, the better the eventual solve
Yeah.
becomes. So that's where my piece of the puzzle comes in.
Got it. And what type of tools do people use? For example, do you use a Python package, or there's some linear solver?
Yeah, luckily there's pretty good tools for this. We use Google OR Tools, which is a Python library, and it has all sorts of different optimization functions that you can use for different use cases. You can set your constraints. Again, I'm not super familiar with this piece of the pie, but I've looked at all the different possibilities, and it looks like there's tons and tons of cool tools that can solve this problem.
Right. I remember in high school we have those type of problem we're just trying to solve it by hands. And you can imagine once you have, say, more than 2 or 3 constraints, I think sometimes it's very hard to solve with pen and paper. And I think when I work with some data scientists in Amazon, they do a lot of simulations for those type of use cases to try to find what is the kind of most the optimal point.
Yeah, it gets interesting when you have many variables because you can no longer visualize it in your mind, right? Once you're past three dimensions. So, I mean, we face similar problems in machine learning when we have high dimensional data. Then it's hard to graph it or even make sense of what's going on. So then you have to rely on your ML algo.
Yeah. And so did you mention that you're working on a time series model?
Yeah, that's right.
So what kind of time series model are you using?
So there's a variety. So the main one is using gradient boosted trees. And we're kind of doing a direct forecasting approach where we have a separate model for each time step out. So it's a little bit different than like the autoregressive methods that are usually taught in school. But I think tree-based models have better performance and are more interpretable. So that's why I chose that formulation.
Interesting. So basically, the features and the target variable they have a lag, and you just use random forest or XGBoost to predict what's going to happen after this lag.
Exactly. So each model is trained with a different amount of lag shifts. So I can predict 7 days ahead or 5 days ahead based on the model.
Got it. Yeah, so basically you can construct anything into time series. It could be, text, it could be images, or it could be tabular data, and then you just need to create this type of lag. And then like you mentioned, and you don't have to always rely on the traditional time series models. You can use random forest, you can use neural network, etc.
Yeah, exactly. As long as you set up all the inputs correctly and make sure that your cross-validation is not, like randomly shuffling. You're doing a time-based, so you don't have information leakage. All these little things that you'll pick up as you fail.
Yeah, time series model is unique. So what are some challenges in building time series model?
Yeah, there's quite a few. I think one of the trickier ones is thinking about the data logistics. So, you might be able to train and test a model that works great, but when you go and deploy it to production and you're running inference, you realize, oh, I don't have this data available at the time when I need to run the predictions. So then you kind of have to go back to the drawing board. I think that's really important to think about from the beginning and making sure that you know what time each data point arrives into your database. That's one of the things. I think the cross-validation also gets tricky. There's, you can do a train test split date, but based on the date you choose, you might not be accounting for seasonality. So then you might want to do something like a nested cross-validation where you have multiple split dates and maybe like a sliding window or an expanding window so that you are truly training and testing across the whole calendar year and make sure that your model is stable for a long time in production.
Yeah. I think for time series model, it's very important to set up this process for validation. And how do you detect certain drift in this time series model?
Yeah, so like we have backtesting dashboards. So we'll check those a couple times a week and make sure that our error is stable, especially compared to the baseline. Sometimes it'll all of a sudden spike. And more often, it's not really due to data drift, but actually something in the back end changes and that data point is not available anymore. So then you got to go talk to the engineering team and be like, okay, what did this property name change or what? So that's the most common failure mode. But definitely there are times when, these customers, their demand grows a lot and your model quite can't pick that up. So you have to go and retrain it or figure out a different way to do your feature engineering or something like that.
Yeah. And it's interesting you talked about how do you investigate when there is a spike or sometimes a drop happens. So besides the changes in the engineering team, what are some other process you go through to understand what happened in the data?
Yeah, that's great question. I wish I had like a play-by-play. Usually it's a lot of detective work. And but I think tracing back to the source is the most common way. Like first, I'll check that my error metric is correct. It doesn't have a bug in it. Then I'll go look at my model inference. Is there something weird happening? Is there an edge case? Then I'll look at the feature table. Are the distributions the same? Are there a lot of null values or something? If that's all fine, then I'll go to the source systems. Like maybe there's something wrong in the ETL. So I think pulling on that string up until you hit the place where it went wrong is the way I'd go about it.
Yeah, thanks for sharing that. And what are something interesting or unexpected you learned when you built those time series models?
So one of the things that was a downside of using these tree-based models is that they kind of suffer from an extrapolation problem. So if you have a bunch of customers that have, let's say, 1,000 units of demand, and it learns those patterns, and then now a customer has 10,000 units, it probably won't be able to predict that 10,000. It's going to reach the end of your decision tree and be like, okay, it's probably 1,100. But if you had a linear model, then it's going to know to extrapolate really well. So these are one of the issues that tree-based models suffer from, unfortunately. It's still okay in our case because we're able to learn from the new data points and retrain and stuff like that. But I think this points to one of my opinions. Like, you don't always need more data or bigger data. You need more variety of data. So if you go from having 1 million records to 10 million records, if they're all the same as the data points that you've seen before, it's not really going to improve your model accuracy much. But if you just add maybe 100 data points on these outlier cases that your model hasn't seen before, that might give you much better accuracy lift.
Yeah. So it's kind of like upsampling for the minority cases, and it's also specifically when you're using XGBoost, it helps with the boosting process, I guess.
Yeah, that's exactly right. It converges faster. Actually, I'm glad you mentioned upsampling, because this is another surprising thing I ran into. A lot of times demand will be 0, but your model might not be good at predicting that, because it'll again predict like a small value, but that's not quite 0. It'll be like 5 or something.
Okay.
And then you'll still like do a delivery of 5 gallons, but then realize like, oh, actually they don't need anything today. So that to solve that problem, I actually broke it down into a classification problem first before doing the regression. So then you can classify when it's going to be 0 demand, and then like, hard line that to 0. Then give your remaining records to the regression model and predict everything above that. That also helps the extrapolation issue a little bit, because it won't underbias your forecasts as much from learning all these 0 values in the targets. So that was one of the things that was like kind of a breakthrough in the accuracy for me.
Yeah, that's a very interesting way to approach this forecasting, because I assume the classification model, you have very high confidence. Is it correct? Or like a very high accuracy? Because the reason I ask is because if your two models have not very high confidence, say the accuracy is around 60-70%, and there are two different models, you're adding a lot of noise in your final prediction. But I assume if the first model has more accuracy, it kind of reduces this type of errors.
Yes, exactly. It makes the job easier for the second model. So you're right. It does reduce that error. And when you evaluate the global error of both the models together, it obviously benefits from that.
Yeah.
So this is called like the intermittent time series problem, which is pretty common, I think, in a lot of supply chain situations. So if you want to use like these nice trees and stuff, you have to get a little creative and decompose it like this.
Yeah. So you mentioned sometimes you have to be creative when you solve those problems. So how do you get those ideas?
Oh yeah. So one way is to get away from my keyboard. You know, go do something that is not staring at a screen. That's when sort of the background processes start working, and then you know, like you'll be taking a shower and have a bright idea, or you'll be on a hike or something like that. So I think a lot of people think like the harder I work and the more hours I put in, the better my output. I don't think that's necessarily true. I think having a balanced life and letting your brain do its thing while you're not actively thinking is actually really powerful.
Yeah. Thanks for sharing that. And previously, I think during our chat, we talked about modern data stack. Can you talk about what are your modern data stack?
Yeah. So I'm really lucky that the company I'm at now has really, really good tools. And so I'll start from the beginning, from our ETL process. We use Stitch and Fivetran to ingest data from like source systems like MongoDB and NetSuite and whatever else. Then we use dbt to do the data modeling, which is amazing. I think that's one of the biggest breakthroughs in data technology in the past couple years, because you don't have to define your DAG anymore. It figures out all the references and does the orchestration for you. You can just focus on writing SQL. So I'm a big fan of dbt. Then for our notebooks, we use Hex. So these are like cloud-hosted notebooks, and they have really nice improvements over Jupyter Notebook. Like they'll have SQL cells, so you don't have to define your connection to your database. Then you can have like table display cells, so you don't have to use pandas.head or whatever.
Okay.
You can kind of click around, and it's interactive like an Excel workbook. And then you can also create data apps out of it really quickly. It has charting tools. It has like pick lists and things like that. So I think this is one of the great things for ad hoc analysis, as well as training ML models. So other than Hex, then for the actual models we put into production, pretty bread and butter Python stack with, you know, whatever machine learning library I need. But then for deployment, we use Kubernetes. So we're on the GCP stack. And I think that has a lot of cool things if you set it up properly. Luckily, I have awesome engineers that set it up properly for me. And like, you know, the Circle CI runs all our unit tests and all that good stuff. So it helps me really focus on the data science stuff and not all the other junk that gets in the way.
Yeah. Thanks for sharing that. I have never used Hex before, but sounds like it's a great tool and I should check it out.
Highly recommend it.
Yeah.
It's not cheap, but I think for the amount of time it saves, it's definitely worth it.
Yeah. And you mentioned you collaborate with engineers. So what does the collaboration look like? Do you involve them in the beginning when you start building the model? At what stage do you start to deliver the model to them?
Yeah, so it's a pretty tightly coupled process. So I attend all of like the engineering stand-ups, retrospectives, all that good stuff. And I have to talk to them to understand where the data is coming from and how I can ingest it and turn it into features. And then I have to talk to them again on how they're going to receive the predictions and you know, how to know when a value is not correct, or when things can go wrong, how to write the tests, all that stuff. So we work together pretty closely, which I think is a huge blessing because I'm not a good engineer. So it's really great to have people around me that can catch my blind spots and you know, help me focus on the data science.
Yeah. I don't think data scientists have to be everything, because we do everything a little bit. Some days you're a product manager, some days you do a little BI, and some days you're an engineer. I think it's important to collaborate with them and also learn best practices from them. And sometimes you do need to also be a teacher to help them understand what are you doing.
Yeah, exactly. I think engineers are fascinated by machine learning. So anytime you can talk to it without too many stats concepts and stuff like that, then it's a great relationship. You can learn a lot from each other.
Yeah. So going back to time series, I know that's something you are working on a lot these days. So what are some common mistakes you see people make when they try to build data time series model, or maybe some mistakes you made when you're just getting into time series?
Yeah. So I think the number one is kind of what I mentioned earlier with the train test split. That I don't know a single time series forecasting person who hasn't had that issue at least once.
Yeah.
There's that. I think one important point I realized is that not all time series are the same. It helps to be able to classify them into different types so you can build models that handle those better. So there's like the intermittent, which we talked about, like you can classify the zeros. There's the smooth time series, which are like great because they're the easiest to predict.
Yeah.
But then sometimes you have lumpy ones, which are not exactly zero, but it's spiky up and down, which is kind of hard. And then there's also erratic. So that's kind of the catch-all category. It's like all over the place. So I think the pretty standard way of doing this is like the time series classification using ADI and coefficient of variance squared. ADI stands for average demand interval.
Okay.
I won't get too deep into it, but there's a lot of resources online if you want to look that up. I think that's a great place to start because it helps you understand how predictable your time series are, and it'll help you figure out which approach you want to start with, rather than just doing a REMA and then failing with that, then going to profit and being like, oh, this still isn't working. You can be a little more targeted if you do good EDA and classification at the start.
Yeah. So besides the metric you mentioned, it's the first time I heard of it. What are some other things in EDA you can detect whether my time series model would work or whether I shouldn't use time series?
I think one thing that gets overlooked a lot is just looking at individual time series. A lot of times data scientists look at very comprehensive things like correlation and histograms and whatever, but looking at specific examples can be really telling because you might see a pattern that you just didn't expect, and you might have a good idea on how to deal with that. Also, when you're making your predictions, definitely look at individual time series too.
Yeah.
Because you might realize you have good accuracy, but your predictions are just flat, which is not that useful for most people.
Yeah.
You want to have some periodicity or things like that. So that's a common failure that I had to learn from and realize, like, okay, maybe I need to change up the approach so that a human looking at this can make sense of it, not just your MAE is minimized.
And so when you build a time series, you mentioned sometimes you predict a week, maybe 2 weeks, you have a different type of lags for your models.
Usually it's okay if those are less accurate because most people don't do that much planning like a month in advance. They care more about like today and like the next next 7 days, for example. But you definitely also want it to be within the range that is useful for someone. Because if it's a complete guess, then you might actually end up telling them the wrong decision to make.
Yeah.
And you don't want to show them those month out predictions. You would want to constrain your model to just be 7 days or something like that.
Yeah, that makes sense. So say if a business stakeholder asks you for a forecasting, say a month out, and how do you communicate, oh, this model might not be so accurate versus like a short-term prediction? How do you communicate risk and uncertainty in your models?
Yeah, so one great way is to show error bands or confidence intervals. So there'll be like the shaded band around your prediction, and I think that's pretty intuitive for non-data people to understand.
Yeah.
The wider this band is, the more uncertainty there is. So maybe if it's really wide, don't trust it so much. That's like a good visual way of doing it rather than saying this has a 95% confidence interval.
Yeah.
Okay, well, what is that?
Right.
For the business people, they might not always love that. And then one way to tackle that issue is if it is inaccurate, you can always go to a higher granularity. Like if you're forecasting demand at the individual item level, it's probably going to be very inaccurate. But if you're doing it at the product category or like the entire business level, then kind of the errors kind of cancel out and you can have a more confident forecast.
Right. Yeah, this is a great way because sometimes when someone asks us a question, we don't really have the perfect answer for them, but maybe we can find some sort of proxy to go up one level, or maybe in some cases find a more specific example in the questions they ask and give them an idea. What is it like for the things they actually care about? So you don't have to just say, oh, I don't know for the specific question. Like what you mentioned, you can find some proxy and then help them understand their problem. And also sometimes maybe helpful, ask them, what made you want to know the answer to this? You might have answer to that. Yeah.
Yeah, I'm glad you called that out. I think it points back to like having empathy for your users. Don't answer their question at face value. See what the deeper problem is they're trying to get at.
Exactly. I think you said it better than I did. And then you mentioned the confidence interval, the confidence band. So for a RAMA model, like usually it will generate those type of band for you, say 1 day, 1 week, 1 month. And for XGBoost, how do you generate those band as time goes by?
Yeah, so one common way is to do bootstrapping. So like random forest, I think is an easier example to explain. Say you train 100 trees. You can take the prediction from each of those trees individually and use that to create your distribution of predictions.
Yeah.
These are actually called prediction intervals, not confidence intervals, but it's a similar concept.
Yeah.
So that's like the default way of doing it. There's a lot of other ways depending on which model you're using, but yeah, that's how I usually tackle it.
Okay. Yeah, that makes sense. And before you just came here for the interview, you mentioned that you're actually going to meet the drivers to check whether your model was correct.
Yeah, that's right. So one of the things I love about this current company is that we're very closely knit with our drivers on the ground that are actually doing the deliveries. They're not working for us. We're actually working for them. We're trying to make their lives easier because they're doing the real work. So a couple of days ago, I got to visit them and do a ride along and go do some fuel deliveries with them and talk to the people that are dispatching them and building these routes. So I can ask them like, hey, where are the demand forecasts doing well and not so well? How can we tackle this? Like for new accounts, there's this cold start problem when we don't know what their demand looks like because we don't have any data on that. So how can we better handle those? And I think it was really insightful. If I had just sat in my room all day and thought about it, I would probably be solving the wrong problems, and that's expensive. So I want to make sure that we're doing things that add value to them and ultimately help the business. So.
Yeah, that's a great story. And so what made you so passionate about working in supply chain?
Yeah. So like I mentioned at the beginning, it wasn't like the thing I expected to get into. It's not that sexy, but the thing that I am really passionate about is solving climate change. And I realized that there's a huge opportunity in supply chain optimization for this because we're burning gas to drive these trucks around or send these shipments over air. And the more efficient we can be, the less carbon we put in the air and in the atmosphere. So that's kind of the thing that gets me out of bed in the morning. And the supply chain stuff is a means to an end. That being said, it just happens to be really interesting from a technical perspective.
Yeah.
So it ends up being pretty engaging for me. But I think the key was that when I was doing my job search, I kind of sat down and thought not about what do I want to do on a day-to-day basis, but which problem do I want to solve in the world? And then from there, I could decide which companies are solving this problem most effectively. And I think that was a great way to go about it because now I never really get bored at work. This might sound weird, but I don't have a case of the Mondays where you're like struggling to start work on Monday. I have a case of the Fridays where I'm like forcing myself to stop working on Friday. It'll be like 9 p.m. and my friends are knocking on my door like, hey, let's go out. And I'm like, okay, let me just start training this model so I don't waste my GPU over the weekend.
Yeah, that's awesome because I think that gives us a different perspective when we're looking for a job or thinking about the career. Great thing I think about for data scientists, you can literally work in any industry. So if you feel you don't know why you're doing this, maybe think creatively. Do you like fashion? Do you like sports? There are people working on those industries. You previously worked at management consulting, and during our conversation, I can tell you're a great communicator. So how does being a good communicator help you become a better data scientist?
Yeah, it's a good question. I think talking data to the business is kind of a topic that no one really teaches you.
Mm-hmm.
You kind of have to figure it out. And what I notice is a lot of people who are very technical or academic, they'll be talking to business stakeholders and everything will just be going over their head because they're using all of the technical terms that no one really understands. So I'm lucky because I came from a business background and I frankly didn't know all these technical terms until I started studying data later on. So I had kind of an advantage that I would already know what the business people like to hear or which terms they're familiar with, how do they like to frame their communications in a way that the main points get across first.
Yeah.
So a couple of strategies for this is to build a glossary in your head of words that business people know and ones that technical people know, and then figure out what the translation is. And more importantly, know which words not to say when you're talking to the business, right? Yeah, you guys can probably figure it out, but that's one thing.
Oh, do you have an example? For example, what are the things not to say?
Yeah. Okay. So let me think of a good one. If you're talking to someone about this new model you built, don't be like, oh, it has 5% MAPE.
Yeah.
Instead, be like, on average, our predictions are off by 5%. Right?
Yeah.
So then they know like, okay, if they have 100 orders, it's either going to be 105 or 95. That really contextualizes it for them. Yeah, that's, I think, one of the most common examples.
And when you're trying to do this type of translation, how do you know you're speaking their language?
You can really tell by their face. So this is why it's good to have your camera on if you're working remotely. Yeah, definitely read the room and see like, are they kind of staring at you or are they nodding? And like be in tune with that so you can repeat yourself in a different way if they kind of look like they're spacing out. So the other key strategy is give them the punchline first. I think in a lot of like academic reports and things, we like to start with the context and the background and the methodology. And then finally at the end, we get to the conclusion and the result that people actually care about. But by then you've lost them. They're not paying attention. And then like you'll leave the meeting and they'll go like, what did we just listen to?
Yeah.
So I think of it as like an abstract or an executive summary. The first thing you want to say is, my recommendation is blank, or this analysis found that, blank. And then let them ask about the background and the context and the methodology if they care. They might not care. They might just care about the answer and then go make their decision. But also, of course, have your assumptions and caveats listed as the second thing, because those could really help guide what the decision ends up being. You might be making this recommendation on like low quality data. Yeah. So you definitely want them to know that too.
Yeah, I think it's important to talk about those things to earn trust. Because if you just say, oh, my model is 100% accurate and people know it's not going to be true. And when you talk about those caveats, I think people know, okay, you're being honest with me. Although it's not perfect, I know where that risk is so I can make my decision.
Yeah. And even if your model is 99% accurate, that sounds great. But if you have an imbalanced data set, then it's not great. So you definitely want to explain that as well, and what that really means.
Yeah, that's a great point. And I like that you pointed out, give people the punchline, because I'm sitting into a lot of presentations when people just spending half of the time giving me context, and also instead of giving a monologue, maybe you can pause a little bit at every few slides, ask people if they're following, do they have any questions?
Definitely. Make it an interactive dialogue, and yeah, let them ask the questions. Have a big appendix and have a short actual slide deck. If any of your listeners want to know more about like starting with the punchline and framing your communications, I would recommend looking at the Minto pyramid principle. This is one of those things I learned in consulting. It's by Barbara Minto, who is like a McKinsey consultant, and she came up with this way of structuring executive communications, and it's kind of shaped like a pyramid. There's plenty of resources and books on it, so I'll let people look it up if they're interested.
Yeah, thanks for sharing that. What are some other books or resources you recommend?
It really depends on what type of data science you're doing. But I think the things that have really helped overall, like the Book of Why,
I
think is a good kind of philosophical approach to data science. We're looking at correlations all day, but no one talks about causality. So I think that was a good read. It's on your bookshelf, I see. So yeah, I'll come back with more examples. I need to think about that a bit.
Yeah. What about on the communication side?
So I think Robert Cialdini's, I think Art of Persuasion, that was a good one, because you might have all the good information, but if you don't frame it in a way that's interesting and inspires action, then it's kind of useless.
Right.
That's a good one. I'll look at my Audible in a second and tell you some more examples.
Yeah, sure. So now you also mentor a lot of new data scientists through project. Can you share what is your approach in helping people to learn data science?
Yeah, so this is through an online data science bootcamp called Springboard. And this was kind of my pandemic project. Instead of like having a sourdough starter, I decided to start mentoring data scientists in my free time. Yeah, so what is my approach to that? I think definitely helping them pick interesting problems to work on that inspires their own curiosity. There's a lot of like, public data sets on Titanic and Boston housing and whatever, but a lot of people don't really care about those problems. So I always encourage them to follow their interest. Maybe they care about sports, so they can do a sports analytics project or stock trading or something that, especially if it's useful for their lives. If they can build an algorithm that they actually use, that's like the holy grail. So that's my number one advice to new data scientists. Follow your curiosity. So when I was in my data science bootcamp, I decided to do my capstone project on Kendrick Lamar's online store, because I was really into his music at the time. And I happened to have a friend who built that website and had access to all the data for me.
Nice.
So I was able to build a recommendation system to tell when people are likely to convert to a customer or not and offer them a flash sale. So that was cool. It was something so interesting. I was staying up till 4 a.m. every night working on it. And I think that's where a lot of the real learning happened, because I actually cared about getting past these bugs and things like that, because the problem was interesting to me.
Yeah, thanks for sharing that. And what is your best advice to data scientists?
So I would say don't spend too much time learning like the most cutting edge, sexy ML techniques or, whatever you hear about on Hacker News. Spend time figuring out which problems you care about, and then use the simplest possible technique to solve that problem first, just to make sure it's solvable with ML. After that, you can experiment with more advanced things and like learn, cool deep learning stuff here and there and see if that solves the problem better. Sometimes it won't. Sometimes linear regression is just the best you can do.
Yeah.
So, I mean, like data scientists, your job is to solve problems, not to use cool techniques. So I think that's one thing to always keep in mind.
Yeah. I can totally agree with that. I think when I just get into machine learning, I want to try all the models I learned from the classes I took. But a lot of times you want to have a baseline, like you mentioned, you want to quickly test whether something works. And especially when there's a lot of ambiguity or data quality isn't very good, if you throw that to a very complicated model, that just adds a lot of uncertainty to it, and then you don't know how to interpret that. So you want to use a simple model, not just to create a baseline, but also make sure you can interpret the results. before you try something more complex.
Yeah, exactly. And the thing I'd add to that is know when not to use ML. A lot of times the business will come to you and be like, oh, we need this cool AI thing built because, it's a buzzword and whatever. But when you start digging into the problem, you might realize, oh, we can actually solve this with if-else logic or something way simpler.
Yeah.
Which is kind of hard to do sometimes as a data scientist, because when you're a hammer, everything looks like a nail. But you might save yourself a lot of trouble and be able to work on more interesting problems if you're able to say, no, actually, let's not use ML for this.
Yeah, that's a great point. And also sometimes when you can't afford to make a mistake, in those cases, maybe you want to have a human in the loop or start with the existing procedure. And once you understand the business case better, and you can start to build your machine learning model.
100%. I think human in the loop is actually crucial for data science and business because a lot of times ML models don't get deployed, even though they're better than the humans, because they don't know who to assign the blame to. So having a human you can make their job way more efficient, but still have a person to validate the results, I think is really good for driving adoption.
Yeah. So what is something you only learned at work that you didn't learn in school?
So how to build things that people actually want and things that actually create value, I don't think you can really learn in school.
Yeah.
Until you start looking at real world issues and real world data sets, that's hard to learn. And speaking of real world data sets, dealing with messy data and knowing which data to throw away is also something you can't really learn in school. I think it's really important to dig into how the data is collected. You might learn things that make you realize, oh, we should actually not build a model using this data. So one example is like when supply planners are doing data entry and they don't know the value, but the UI requires them to put something in, they might put a junk value like 999 or whatever.
Yeah.
And it's not going to show up as a null, so your drop NA is not going to get rid of it. You don't know that until you start looking at the distribution and talking to the people on the ground entering the data to realize what you need to filter to make your data quality better.
Yeah, those are some great advice. I feel that when we just started our career in data science and you feel frustrated, oh, I have to deal with the messy data. I think instead of call it data cleaning, a lot of time is data understanding or business case understanding. I think take advantage of the time when you just looking at the data and then be a little bit patient before you put the data into your model.
Yeah, and it's hard sometimes when you have a deadline. EDA is the thing that can take as long as you want it to. So sometimes people just skip over it and it could bite you in the end.
Yeah. And do you have a mentor?
Definitely. Many, but I'd say my main one is my current manager.
What is something most important you learned from your current manager?
He's taught me to develop an independent perspective and don't be afraid to raise a controversial opinion because you're not really adding much value if you're just telling people what they want to hear. You're really more valuable if you're telling them something that they haven't heard before, or even if it goes against the grain or it's completely the opposite of what the business is doing. If you're the one to speak up and defend your position, you might save the business from making a really costly mistake.
Yeah.
And I think data people are in a unique position to do that because we're looking at the reality in the data. A lot of times, when you're on the business side, you're having these ideas and discussions and things, but it might not be grounded in reality. So we have a unique opportunity to bring people back to, what's actually happening.
Yeah. And if you are to mentor someone new to your team, what's your best career advice for them?
I think it would be pretty similar to what I shared about my Springboard mentees. Really find out what you care about and what types of problems you're interested in solving, and use that to kind of guide your curiosity. Now, this is tricky because the business problems might not always align with what you're independently curious or passionate about. So there can be a little bit of give and take, especially in the beginning of your career. And in that case, be open-minded. Like for me, I didn't think I would be in supply chain, but look at me now. It's like one of the most interesting things I could imagine working on.
And what are some mistakes you made in your career?
So not knowing how to write tests was a big one. Like I said, I'm not an engineer. So when I was deploying ML models, we kind of just went in YOLO mode. And as soon as we got good accuracy, we'd deploy it. But then realized sometimes the predictions were just like something that you wouldn't expect. And being able to write a good validation suite and write test cases and unit tests and all that stuff, that took me a while to figure out.
Yeah.
And I'm glad I have good engineers that could teach me that because, those led to some pretty painful mistakes.
Yeah. Thanks for sharing that. I think that's like a very important skills for data scientists to acquire that can change your mindset and how to build more sustainable data science pipelines.
Yeah, exactly. And I think the new focus on like ML ops really brings that perspective in, writing good tests and making sure that models are robust and sustainable.
Yeah. So how do you see yourself grow in your career?
Yeah, that's an interesting question. It's something I'm still trying to figure out. I think I want to go the path of management and being able to make more strategic decisions, helping to mentor other people and focus on the most important problems. But also I love writing code and I love training my own models.
Yeah.
So I want to keep doing that too. I think I want to be a tech lead where I'm kind of leading from the front lines, helping a team out, but also still reviewing a lot of code and making my own commits and being able to solve problems on my own as well.
Yeah. And what do you think about the future of data science, specifically in supply chain or maybe helping the environment?
Yeah, I think there's a lot of opportunities ahead of us, and the state of data science and machine learning in supply chains is still pretty nascent. Unless if you're like at a big tech company like Amazon, like of course you guys are doing some really cool advanced stuff with supply chain, but there's tons and tons of other enterprises out there that are still using Excel spreadsheets for figuring out their supply plan. So there's a lot of work to be done, even with the simple methods that can give us a lot of benefit. And I really hope more smart people start working on those problems.
Yeah, thanks for sharing that. So what do you like to do when you're not working?
I'm pretty big into martial arts. So I've been doing that since I was 10 years old. I try and do one style or another at every point in my life.
Yeah.
So recently that's been Tai Chi. That's been really cool for helping like just calm my mind when I'm done thinking about technical stuff.
Yeah.
That's a big one. I really love music and music festivals. I think that's also a great way to connect with people and kind of like get rid of some stress and just like staying active and healthy. I love cooking and just, living a balanced life.
Yeah, that's great. And how do you keep learning new technologies, new models, ML ops?
Yeah, great question. It's a little daunting at times because this field is growing so fast and there's so many interesting topics to learn. There's, all these cool things that OpenAI and DeepMind are doing. And I'm like, oh, cool, I should learn reinforcement learning. But then actually, what is that going to help with in business?
Yeah.
Because we don't have great simulation engines or anything like that. So I think like there's a bit of give and take. I try and spend half my time studying topics that'll be directly useful for my work. And then the other half, I just follow my curiosity and, just find a cool article and then, find some course that teaches that technique. And maybe, down the line that ends up being useful for a project. But I think it's also just satisfying from an intellectual curiosity's perspective. And then the other thing is to have mentees that can push me to learn more because maybe they'll be interested in a topic that I don't know that well.
Yeah.
And they want to talk about it. So I have to go and study it and figure it out so I can actually help them out.
Yeah.
So that's a good forcing function for me.
Yeah. A great way to learn is to teach and explain something to people.
Exactly. I don't think you've truly learned something until you try explaining it to someone else.
Yeah.
Because that's when you realize like how much you don't know.
Mm-hmm. Are there other side projects you're working on right now?
Yeah, one of the ones I was working on recently was the models that power Project Drawdown.
Mm-hmm.
You mentioned this at the beginning. They're an organization, a nonprofit that's trying to prioritize the top 100 most effective solutions for climate change.
Yeah.
So things like solar energy, plant-based diet, different agricultural practices, this and that. So I was working on their open source code base to try and implement their models in Python and make them more accurate and performant so that they can do this prioritization more effectively for different regions and geographical areas.
Mm-hmm.
That was really fun because it's like very directly working on the problem I want to solve. And it was kind of low stakes because it's just volunteer based. So there's no like deadlines. And if I make a mistake, then there's other contributors that can help and things like that. I'm really glad I worked on that. That actually led me to be an advisor for a startup based out of Iceland called So Green. Yeah, they saw the work I did on one of the models that's around health and education, and now they're creating a carbon credit system for that. So I'm helping advising them and making sure their model is working, and some strategic things here and there.
Yeah.
So yeah, I think that's another example of just following your curiosity and seeing where it takes you. There's an endless amount of opportunities out there.
Yeah.
If you're just authentic and stay true to what you care about, then they'll come find you.
Mm-hmm. Yeah, that's awesome. And what is something in your life or career right now that you're excited about?
Honestly, I'm really curious about these image generation AIs, like Stable Diffusion and DALL-E and things like that. Mm-hmm. I'm really curious on which industries these are going to transform in the coming years, and how we can kind of like leverage those and make our world more efficient, like design, art, things like that. I'm really excited to see what comes.
Mm-hmm. And what about your own career and life? What are something you're excited about?
Yeah, I'm really excited to like build a data science team. Mm-hmm. Right now, we have 2 data scientists at the company, and we're planning on growing pretty quickly, especially as we deploy more and more machine learning models. I'm really excited to get a really good ML ops workflow in place. That's something I've never done before, so it's kind of exciting. It's a time to learn and see like how much we can scale this with the company and make sure that everything we're doing is actually providing business value. Mm-hmm. We're not just building models for the sake of building models, but like people are actually excited and come back and say, hey, we want more of these.
Mm-hmm. Yeah, awesome. Well, it's great to have you on the Data Scientist Show and sharing your journey with us.
Thanks for having me, Daliana. This was a lot of fun.
Thank you.